Okay, the continuity correction for using, well, basically binomial to normal. So it's dead simple. So what I'm going to do is I'm just going to show you the continuity correction, assuming you know what's going on anyway. So okay, say you got binomial like this, 90 0.47. Okay, don't forget that's your N and P. Okay, it goes use a normal approximation. Use normal approx to find probability of x greater than or equal to 35. Okay, so first thing, you know, just for the sake of it, can you see P is roughly equal to a half, N is large, whatever the hell that means, they're never clear on it, okay? So it means that we can. Remember, there's also, if this doesn't happen, you can still do it. You can still do it as long as N times P, so you know these two numbers, is greater than 5, and N1 minus P, so that'd be like 90 times 0.53 is greater than 5. I just thought I'd throw that in just in case. I wouldn't be shocked if they test that, especially with their tendency to do little details. But anyway, on to this, okay? So the first thing we do is we understand that this can sort of be approximated using NP, so 90 times 0.47, so 42.3 times 0.53 as well, so the variance of this 1.9, okay? And we're trying to find probability of x greater than or equal to 35. So let's kind of just remember how the continuity correction works. So in the binomial, you know, you've got your 34, your 35, your 36. So what would have happened is we would have wanted all of this. Does that make sense? Yeah, we want the 35. Now, whenever you're doing the continuity correction, look, yeah, because the normal, so the binomial has jumps, you know, 34, 35. The normal is like a nice straight line. So it's wrong to, if I kind of say, by the way, I should probably call that a different letter, like y, okay? It's, you don't say probability of, oh, that. It's wrong. Because, you know, you're missing that. Basically, can you see the halfway line is 34.5? So in the binomial, why we wanted that, for the normal we want, it's actually 34.5, which we want here, okay? That's how you do the continuity correction for that one. And you know, you just make sure you get check this answer with me once, and then I'm going to show you how to do all the rest of them. So this one will be lower, 34.5, upper, huge, mu. Oh crap! Okay, 4.73487. and mu is 42.3. The answer is 0. So the answer you should get here is 0.9503. Okay, that's how you do the continuity correction. And let's just kind of look at if there were a few different things which I was trying to do. So imagine I was trying to do probability less than or equal to 16. The way I do it, I think about the binomial. You got like 15, 16, 17, so on and so on. So in terms of that, can you see I want everything on that side? So if you're kind of thinking of a normal, which is like a continuous line, can you see that that would be 15.5? So I want all of that. So to do that, this would be the equivalent of me saying that the normal is less than 15.5. Does that make sense? I have a feeling it might have already clicked for you. No, let's just do it. Let's go through the 4 different types then. X greater than 20. X less than or equal to 32, X less than or equal to 44, X greater than or equal to 7. Okay, so try do all of the continuity corrections for this one. First, I'll just write it, what this one should have been. So this one should have been greater than 20.5. If that one doesn't make sense, don't worry, for each one of these I'll give like a quick explanation, which you can feel free to skip for the ones which you know are correct. Oh yeah, I should do this one as well. So if I kind of say, you know, x is greater than or equal to 8 or something like that. Yeah, so, and then finally we'll look at that as well. So try that. This will be y less than or equal to 32.5, probability of y less than 43.5, x greater than 6.5. Okay. And remember, it doesn't matter if I do the less than or equal to's on the normal distribution. Probability that anything's equal is 0, so they're virtually the same. Now for this one, what would you do? This one will be, so let's actually think about this one, okay? So we want it in the terms of, so you know, imagine you got 3, 4, 5, and you got 7, 8, 9. The best thing is always with the diagram for this one. So you want it greater than 3. So you need it, sorry, you don't want 3. You want it to be greater than 3. Well, this is a bit of a dyslexic number line, isn't it? Okay. Alright, so you want it great. Remember, that's kind of saying like x is greater than 3 and x is less than or equal to 8. Don't know what that is. Okay, so you'd want it this side. So think about your 3.5 going all the way to, you want to include 8. You do want to include 8, so you're 8.5. So this will be the same as saying like 3.5 y 8.5, and you could do the normal distribution with those as your higher and lower. We might as well just practice 1 or 2 more of those. Let's kind of say this is 12, and that's greater than equal, less than equal to, and that one's a 20. Let's just kind of flip the sign, but it's just thinking that matters. So okay, here's the way you do it: 11, 12, 13, and so if I kind of 19, 20, 21. So if I kind of see that, I know I want greater than or equal to 12, but I want less than 20. I just like to do that. I think it makes it clear for me. So less than 20, I want all of that. I actually don't want 20. So can you see that's 19.5? I'm going to need all the way to greater than or equal to 12. That means I want to keep 12 as that, so 11.5. So that's a really nice, easy way of doing this one. Did I actually do this in good time? Yeah, great time, great time.